cathode ray tubes. Let's dive into the history behind them. CRTs were first invented by Ferdinand Braun in 1897. Before we look into the progress that was made by CRTs, we need to look at what happened before they were invented. Cathode rays was first discovered by Julius Plucker and Johann Wilhelm Hittorf. Then in 1890, Arthur Schuster and William Crookes showed that cathode rays could be deflected by electric and magnetic fields. Then J.J. Thomson in 1897 measured the charge to mass ratio of cathode rays, showing that they were made up of negatively charged particles, which were smaller than atoms. Finally, cathode ray tubes were invented by Ferdinand Braun in 1897. They were constructed from a cold cathode tube with a phosphor-coated screen. Now we look into the progress that was made by cathode ray tubes. In 1908, Alan Archibald published a letter in the scientific journal Nature in which he described how distant electric vision could be achieved by using cathode ray tubes. The first cathode ray tube to use a hot cathode was then developed in 1922. In 1926, Kenjiro Takayaganagi demonstrated a CRT television that received images with 40-line resolution. Then in the 1930s, Alan B. Dumont made the first CRTs to last over 1,000 hours, leading to the widespread adoption of the technology. Then from 1949 to the early 1960s, there was a shift from circular to rectangular CRTs, which was followed by the invention of the first color CRT produced by RCA in 1954. The size of CRTs gradually increased over time from 19 inches in 1938 all the way to 43 inches in 1981. Now we move on to the construction of CRTs.
Okay, so the CRTs are divided into three parts: electron gun, the electrostatic deflection plates, and the screen. The electron gun is the source of electrons in the apparatus. It consists of a heated cathode, a grid, pre-accelerating, focusing, and accelerating anodes. Electron beam is released from the heated cathode, passes the nickel grid, which is coaxial with the CRT, and it's focused by the focusing anode and it's accelerated by the accelerating anode. These both are cylindrical with a small opening in the center. The pre-accelerating and accelerating anodes are at 1500 volts and the focusing anode is at 500 volts. Next, they come to the electrostatic deflection plates. These plates produce an electrostatic field in only one direction, making the beam accelerate in only one direction and not move in other directions. Finally, the beam strikes the screen, which is also called the faceplate. Its internal surface is covered with phosphorus, which converts electrical energy to light energy. Now, there are two phenomena associated with it. The first one is cathodoluminescence, which is when electrons strike the phosphorus crystal, it raises its energy level. And the second one is fluorescence, which is when light is emitted from the crystal because of the excitation.
Now we'll talk about the working principle of a CRT. So the working of a CRT can be distributed in three parts. The first part being electrostatic focusing. The focusing used in a cathode ray tube is analogous to refraction of light beam through a compound lens system. As light beam can be focused, varying the focal length of the system, the electron beam can also be focused onto the screen to offer a fine spot of illumination. Talking about electrostatic deflection, a potential is applied between two parallel plates. A uniform electrostatic field is produced by these plates in the y direction. Thus, entering electron will experience a force in the y direction. The electron beam moves towards the positively charged plate. Similar plate setup is arranged perpendicular to these plates, which control the movement of electron beam in the x direction. Next, we'll talk about closed deflection acceleration. So after passing beyond the deflection plates, the electron may or may not experience additional acceleration, but this primarily depends on the maximum frequency applied to the CRT. Electrons then hit the phosphor-coated screen, and due to its property, wherever the electron strikes, it glows. Let's recount the steps of how a CRT works. So first, heater heats the cathode and ejects the electrons. Second, pre-accelerating focusing and accelerating anodes focus and accelerate the electron beam. Third, horizontal and vertical deflection plates determine the direction and position of the beam. Fourth, beam hits the phosphor-coated screen. And fifth is when we see the image on our screens. This is an image of a cathode ray tube. We can see at the start, at the leftmost side, there's the electron gun and the grids. Then we see the pre-accelerating focusing and accelerating anodes, which accelerate the beam. And then there are vertical deflection and horizontal deflection plates to control the direction of electron beam. The green coating is the aqueduct, which keeps electron from hitting the sides. Finally, we'll talk about the disadvantages of a CRT.
One of the notable disadvantages of CRT monitors and television sets is size. They are large, heavy, and bulky. CRT display technology is also dependent on size. Bigger and wider screens require bigger tubes. Another drawback of CRT is that it displays images with fewer pixel densities when compared to modern display technologies. In other words, the CRT's Gaussian beam profile produces images with softer edges that are not as sharp as an LCD at its native resolution. Imperfect focus and color registration also reduces the sharpness. All colored CRTs produce the Moire pattern. CRT monitors used to be more expensive than LCDs because of high manufacturing cost. Another disadvantage is that they consume a large amount of energy. For example, a 32-inch LED TV requires 18-watt energy, whereas a similarly sized CRT TV requires 125-watt energy. CRT is a vacuum tube. The vacuum allows electron beams to fly without colliding with molecules of air and gases. Damage to the glass or any surface of CRT can collapse the tube that can result into implosion. Thank you.